In the past, we've solved square root equations by squaring both sides to undo the square root. We can do a similar process when dealing with cube roots or fourth roots. So let's go ahead and take a look at a few kind of simple examples for when we're working with radical equations. Now, first thing, we want to make sure that the radical we're working with is isolated. So if there were anything outside of that radical, we'd want to move it to the other side of the equation first. And on the next slide, at the end of this video, we'll take a look at one of those. In this example, in fact, in all of them on the screen, all of our radicals are isolated. So I see that I'm dealing with a cube root. Well, the opposite of taking the cube root of something is to cube it, to raise it to the third power, just like the opposite of taking a square root is to square. So I want to do the cube root of both sides. Cubing a cube root will cause those to cancel out, leaving behind just 2x plus 7, and then I'll raise 3 to the third power as well and get 27 on the other side. From there, it's a very simple linear equation to solve. So I'll subtract 7 from both sides, and then divide by 2, leaving me a final answer of 10. Now I'm going to start to circle my answer, but then I'm going to wait and put on the brakes just for a minute. If you recall from when we dealt with square root equations before, when we're working with radicals, we always need to check our solutions, because sometimes we do all the work right, but once we go back and plug that answer in, it does not check out, and we have to reject that answer. We'd call it an extraneous solution. So let's take a look at this 10 and see if it does check out. So I've got the cube root, and you can do this in your head if you want to. I just want to show you one of these. So 2 times 10 and then plus 7, I want to do the cube root of that and see if it's equal to 3. Well, 2 times 10 is 20, and adding 7 to that gets me 27. And yeah, the cube root of 27 is 3. So this one does check out. I can go back and circle that answer. Okay? Just be in the habit of always checking. You know the one time you don't check is going to be the one time that it doesn't work out. This next example to the right of that problem looks a little bit different. You've got cube roots on either side. Well, the cube roots are isolated, so doing what we did last time, let's just raise both sides to the third power. Well, you see right away what's going to happen is, well, both cube roots just cancel out. In fact, you've got the same thing on either side of the equation, the cube root, so we can just cancel it out or ignore it. So I'll drop that off both sides and get negative 2x plus 9 is equal to 2x minus 7. Once again, hopefully a very easy linear equation to solve. I'm going to add 2x to both sides to get the variables combined over here. At the same time, I think I'm going to add 7 to get the constant moved to the other side. So I end up with 16 is equal to 4x. And dividing by 4, I come up with an answer of 4. Once again, I'm going to start to circle my answer, but then stop, put on the brakes, and go back and check that. At least do a mental check to see if it works out. So this time, plugging in 4 for x on both sides. Let's see, I'm going to try to do this one a little bit in my head. So negative 2 times 4 is negative 8. Adding 9 to that gets me a positive 1, so this side works out to be the cube root of 1, which of course is just a 1. On the other side, I will do the same thing, plugging in 4 for x. 2 times 4 is 8. Subtracting 7 again is 1. So I get cube root of 1, and yes, that's the same thing on both sides, so it checks out. So once again, we have a solution, 4. All right, let's take a look at one more on this screen, and since I've been talking all about solutions that don't work, you can probably guess what's going to happen this time. The square root is alone on either side, so I'll start just by squaring both sides, or once again, just get rid of it. It's the same thing on both sides. So I get negative x plus 3 is equal to 3x minus 13. Now, nothing tells us that this is going to be a solution that doesn't work out. There's nothing weird about it so far, so let's just keep solving it. It's not until we get to the very end and check it that we would have see that there's going to be an issue. So I get 4x. I'm going to add 13 to both sides. And once again, I get an answer of 4. Oops, not 13. 16. But once again, once I divide, I get an answer of 4. Before I circle that, though, remember we do need to check these, and so watch what happens when I check this one. It's kind of interesting. I'm going to plug in 4 for x, so negative 4 plus 3 gets me negative 1. So on this side, I end up with square root of negative 1, which is interesting. We don't usually do square roots of negative numbers, at least not to get nice real answers. Plugging in 4 for the other x, 3 times 4 is 12, subtract 13, I get negative 1 again. So at first glance, it would seem that, yeah, we get the same thing on both sides. However, turns out that when we check these solutions, not only do we need to get the same answer, we have to make sure that there are no imaginary answers in our check. Because the square root of negative 1 is imaginary, I actually need to reject this answer. Turns out that there is no answer to this problem. So I'm going to say there's no solution. We'd say that 4 is an extraneous solution. It seems like it will work, but once we try it and check it, it turns out it doesn't, because we cannot get imaginary answers when we check. let's take a look at just one more example when we're solving with radical equations. As I mentioned in the previous slide, we have to make sure that before we do any squaring, our radical, or squaring or cubing or whatever, that our radical is isolated. So if there's anything outside the radical, in this case the 6.3, we need to take care of that first. I'm going to start with dividing both sides by 6.3 to get rid of that 6.3 that's being multiplied. Okay? Don't do any squaring until the square root or cube root or whatever is isolated. So dividing this out, I come up with 8.65, if I round that off, is equal to the square root of 1013 minus p. At this point now, because the square root is isolated, now I can go ahead and square both sides, and I'm squaring since I was dealing with a square root. That gets me about 74.82 is equal to 1013 minus p, and once again I have a hopefully very simple linear equation to solve, so I'll subtract 1013 from both sides, leaving me negative 938.18 equal to negative p, and if I divide both sides by negative 1, or if I just change my signs, I end up with positive, p is equal to positive 938.18. Now I should check this one as well, and I'll leave you guys to do that on your own. If you check this though, you may not come up with exactly 54.5, and if you think about why, it's because we had rounded off some numbers in this case, but your solution when you check it should come out close to that, 54.49 or something. If it comes up 72 or something way off, then something's probably gone wrong, but remember, we may not get exactly that because we've rounded, but we should check the solution.